Let's process some X3 data given to me by GVI. I'm going to use LiGeorefrence to post-process this data out of a X3 sensor that GVI just came out with. First things first is open up LiGeorefrence. We're going to browse to the project. Let's see, demo data X3. So right off the machine, you're going to pull off this folder right here. There's a little bit of prep that we want to do beforehand. So what I'm going to do is open this folder, So this is going to be the same folder. Here we go. So this folder has our base station data in it, observation file, whatnot, in there. And then this is pretty much the folder we pulled off the GVI unit. Inside, every time you pull anything off, it's going to be by date, and then inside it's going to have the folder hierarchy and everything in there too. So then I'm just going to take my base station files, I'm going to copy it, put it in my base folder. All right. Images were in this folder already for me, but for the most part, I'm not 100%. I haven't actually gotten an X3 unit to play with yet. But with the V70, you take the card out, and then you offload your images, and then you just end up putting the images inside the cam1 folder. So you dump all your images in there. And then besides that, that's pretty much all the prep you need to do on the back end. So what I'll do next is I'll browse for my project. So demo GVI X3 here, and I'll click on the live file. My file is loading up. And what should happen next is I want to see the trajectory. So this is the trajectory of the mission that was followed. So now what I'm going to do is I want to go through and just split out this trajectory. You have a couple different ways you can do this. You can click auto split. I'll kind of auto split it by timing and angle and things like that. You can do select on trajectory, where actually I'll just do that. You can do it like this, and I'll select the trajectory line. And the other thing you can do is draw polygon. So I'm going to draw polygon over the data. So anything on the inside is the data that I'm going to keep. I'm going to do trajectory, and then it splits that out. And then we hit this little button to turn things on and off of what's going to be kept and what's not. This is also where I like to just go through and delete the lines that I don't really care for. So I don't really care for that one. I'll check that. I don't really care for that too much, so I'll check that one too. So I only want to process these 3 flight lines. I'm going to delete those. Perfect. So we'll go into settings. We'll check a couple settings. So in here, this is the main thing that you have to be focused on. So for this, our base station data is going to be Rhinex. And then we're going to go into base. Usually it'll populate. And then since I did not send it out to Opus and I didn't get an Opus solution, I'm just going to pull it from the header. Or I can average it out. Either way, it's fine. But everything should be fine. Your laser settings should auto-populate, camera settings auto-populate. This is pretty much the main thing you got to focus on, and that's usually just entering in your known point or your Opus solution. But since I don't have one, I'm just going to pull it from the header of the base station file. Target coordinate system, this is where you can go through and set your target coordinate system. For now, usually in my own workflow, I kind of export everything out in WGS84 in orthometric height, and then in other software, I can go through and change everything up But it really just depends how you're processing it. There are times where I will change this data right here and make sure my point cloud is in WGS84, but so it'll hide. Again, it really depends on how you're processing the data and what software you're using. But for this one, I'm just trying to process out the point cloud so you can see what the X3 data looks like outside of what we captured. So this is good to me. I'm going to click OK. Oh. Okay. Next is going to be the pause process and georeference. You can go through and do classification. You can do smoothing. I'm not going to do those too. Decolorization. But for the most part, in terms of our workflow, usually I'll go through and take it into a third-party program, such as like Trimble Business Center. You can even take it in the LiDAR 360. But there are a couple of different ways you can go through, and it really depends on your software and how your workflow is on how you want to do it. But in general, I kind of just want the georeference colorized point cloud, and then I will go through and remove noise or outliers and things like that in a third-party program where I'm going to do my extraction too. There are a lot of ways to do it, but again, it's a whole nother video. But for now, I'm just going to do the pause process, georeference. This usually takes a little longer time, but usually when you process the data, you do these two first, and then if it works out, you can do the colorization afterwards. So right now, all I'm going to do is hit start. Now it's going to post-process that data. So right now it went through and did the post processing, POS, post, and then now it's going through and georeferencing or tying together the point cloud file and the corrected trajectory together. So after this, we should get the PPK'd point cloud data out of this. So give it a couple more minutes, but pretty much after this, you don't even have to colorize. You can export that point cloud out and start doing your extractions unless you really want the colorization. Then you can do the colorization and then export it out. So I'll do the colorization too in the next step. But for the most part, we'll take a look at the data. In general, we'll also go through and run the bore site calibration. And if bore site calibration isn't enough, we can go through and do the trajectory adjustment. But we'll cut a profile in a minute, probably like somewhere around here. And then we'll take a look at that data. And we'll see how much better we can get it with the bore site. And then if we have to, we'll go through and do trajectory adjustment, or we can do it regardless. So. All right. So here's the data. Let's go by height. So as we can see, by height it looks pretty good. You can see that there's a power line. Something in here. I'm not sure what it is. Go a little bit further down over here. Take a look at data. Looks pretty good. And then let's cut a profile. So this is in meters. I'll say 0.1 meter profile. And then we'll cut it across. Now if we look, let's change the colors. Do random colors. Well, let's choose one. Yeah. All right. So now if we look, zoom in. This is where it looks like all 3 point clouds converge. So this is straight out of the sensor after the post process and everything, and it looks pretty good. Let's see. It looks like there's some misalignment over here. And let's measure this. I'll go to measure. That's a pretty high point to here. So that's in meters, so 0.13 meters. The Y for density or for thickness. And then how about now we'll do bore site calibration. So for this, we'll go calculate. We'll apply it. So these changes that happen right now, when I click yes, it's actually going to correct the point cloud files. So there's no going back. So usually in most workflows, what you end up doing is you create a separate file with the backup raw data, and then you edit all your data in a different file folder. So that way you'll always have the raw data too. In the case you kind of screw something up here, you can still have a backup data set to go through the workflow again. So I'm just going to hit yes because I have backup of this data. All right. So again, let me see. Changes. They could calculate. We're applying the changes again. Pretty much what this is doing is it's going to give a tolerance of, was it 5 degrees in the roll, pitch, and heading. And it's going to try and get it a bit closer, which it actually did. So the first thing you do is you hit calculate. Once it calculates it out, you hit apply, or you can hit preview to preview the changes, and then you hit apply to apply the changes. But as you can see, it definitely closed it up a little bit. So let's go here. I'm going to pick 2 thickest spots. 0.138. But then overall, you can see that the magenta colored flight line that was flown is better matched up with the rest of them. One other thing you can do past just the bore site calibration that I could recommend you could do too if or site calibration isn't getting close enough, you can do trajectory adjustment. So this will actually go through and tighten it up even more, but in a different manner. Go. Effort to make this video shorter. I am going to. Alright, there we go. Calculated and the trajectory adjustment. But I mean, overall, if you look at it, that thickness isn't bad at all. I mean, doing it all within tolerance of any other sensor that I've used. Another profile. Overall, it's a pretty good one. Definitely a bit noisy, but I haven't gone through. It is noisy, but I haven't gone through and removed outliers or noise removal or anything like that. But now I like the way it looks. Now I can put a little more time into it. I mean, you can do point cloud smoothing. You can do smoothing and classification, but again, I usually do that in another program, a third-party program. So right now I'm just going to do the colorization, and I'll hit start. Nope. Gotta escape out of that. I'll hit start, and then now it's going to go through, and if everything matches up, so your timestamps and the number of your photos, it just immediately goes into the process. So again, so this video isn't incredibly long. I'm going to. Alright, that didn't take too long at all, but now you can rotate this around. Turn off. Zoom in. This is a really big parking lot. Again, I have no idea what this data is. Looks like an airfield. But I mean, the deal looks pretty good to me. Can't say anything bad about it. But that is the X3 LiGeorefrence pretty much run through of how to process that data within LiGeorefrence. So if you have any questions, feel free to reach out. I'm Jeremiah Wong. I'm from Frontier Precision from Frontier Precision on End. So yeah, if you have anything, just let me know. You can find me at Jeremiah at frontierprecision.com. Cool.